Q5159. While holding the angle of bank constant in a level turn, if the rate of turn is varied, the load factor would A. Remain constant regardless of air density and the resultant lift vector. B. Vary depending upon speed and air density provided the resultant lift vector varies proportionately. C. Vary depending upon the resultant lift vector. The correct answer is A. The rate of turn changes with the airspeed at any given bank angle. In other words, the rate of turn will change depending on whether the velocity is increased or decreased while the degree of bank is maintained constant. As a result, the centrifugal force for any certain bank remains constant. The load factor stays the same as a result. 5017. If an airplane category is listed as utility, it would mean that this airplane could be operated in which of the following maneuvers? A. Limited acrobatics, excluding spins. B. Limited acrobatics, including spins, if approved. C. Any maneuver except acrobatics or spins. The correct answer is B. Utility category aircraft are capable of performing all standard category maneuvers as well as certain limited acrobatics, including spins in approved. 5196. Stall speed is affected by A. Weight, load factor, and power. B. Load factor, angle of attack, and power. C. Angle of attack, weight, and air density. The correct answer is A. The suggested stalling speed is unaffected by changes in air density or angle of attack, since the critical or stalling angle of attack for a particular airplane is fixed. 1. Weight is a factor that influences the estimated stalling speed. The stall speed rises along with the weight. 2. The load factor, bank angle. The stalling speed rises as the bank angle does. 3. Power. The stalling speed will be reduced with more power. 5211. The stalling speed of an airplane is most affected by A. Changes in air density. B. Variations in flight altitude. C. Variations in airplane loading. The correct answer is C. The load factor has the biggest impact on the indicated stalling speed. The square root of the load factor has an impact on the airplane's stalling speed, although changes in altitude, air density, have no impact on the indicated stalling speed. 5206. Recovery from a stall in any airplane becomes more difficult when its A. Center of gravity moves aft. B. Center of gravity moves forward. C. Elevator trim is adjusted nose down. The correct answer is A. When the center of gravity, CG, of an airplane moves aft, it shifts the balance point towards the tail of the aircraft. This can result in decreased stability and a more pronounced tendency for the aircraft to pitch up during a stall. As a result, the recovery from a stall becomes more difficult because the aircraft may be more prone to entering a deep stall or experiencing a more abrupt and uncontrollable pitch-up motion. On the other hand, when the center of gravity moves forward, it enhances the stability of the aircraft and provides a natural tendency for the nose to pitch down during a stall, which aids in recovery. The elevator trim adjustment, C, refers to the control surface that helps maintain the desired pitch attitude of the aircraft. Adjusting the elevator trim to a nose-down position can aid in reducing the pitch-up tendency during a stall and may facilitate recovery, depending on the specific aircraft design and trim settings. However, it is not the primary factor affecting the difficulty of stall recovery. In summary, an aft CG position makes stall recovery more difficult due to decreased stability and increased pitch-up tendency.